So we're going to really start combining things that we've learned. That's what is happening all throughout this course. We learned something new, we put them together. Then we learned something new and we put all that together. So division with fractions with variables in them. Oh, this is going to be fun. Okay, so we're going to start off with 5x over 6 divided by 5. So, what we just learned in the last video was when you are dividing with fractions, you multiply by the reciprocal of whatever comes after that division sign. So we still have 5x over 6, but now we're going to multiply it by the reciprocal of this thing. And a whole number starts as 5 over 1. The reciprocal is 1 over 5. Okay? Then we have it as multiplication. And again, one of the benefits of having things written as multiplication is we can cancel. Okay? Multiplication's great. I immediately see that I have 5 times x, and then diagonally across from it, I've got a 5, right? So a numerator with 5 and a denominator with 5, those 5s just cancel. And nothing else cancels, so we multiply straight across. X times 1, and then 6 times the one that's left over there. X over 6. 5x over 6 divided by 5 is x over 6. That wasn't so bad now, was it? Let's look at another one. So, negative 45x divided by 9x over 7. Pause the video, try it yourself, and come back. So I stare at it, right? We always pause and look at our problems before we try something. I notice that there are fractions. I notice that there are variables. I notice there's a negative. I notice it's division. Those are all things to just stop and observe. And then I start thinking about how I'm going to do it. Division with fractions, I think I've got to divide by the reciprocal. And I remember which one I do, and it's always what comes after. So I'm going to change this to negative 45x times the reciprocal of 9x over 7. So remember that x is going to go with the 9, right? It's the reciprocal of the entire thing. It's now 7 over 9x. Because remember that x is a number, so 9x also represents some number. 9x represents whatever 9 times x is. So this whole thing is now going to be in the denominator. So now we have multiplication. Just for my own sense of security and to make sure that I have everything lined up right, I'm going to put that whole number term over 1. And because it's multiplication, I'm going to work to cancel stuff. Now we're starting to get a little more complex. So this is where those prime factorizations really can start to come in handy. So I'm going to rewrite each part of the fraction as a product of the prime numbers. Negative 45x would be negative 1 times 3 times 3 times 5 times x. That's its prime factorization. Do a factor tree and you'll see that. Over 1 times 7 on top, that's a prime number. And 9x can be rewritten as 3 times 3 times x. Okay, so I did all 4 parts. Factor them into prime numbers, and now we cancel. Again, by doing the negative 1 as its own, its own number, as its own part of the factorization, we're not going to lose it along the way. From left to right across the top, we're going to cancel 3 with the 3, 3 with the 3, x with the x, and that's it. Maybe you like to circle what's left. Maybe you like to highlight. I like to highlight. I like to go through and make sure I didn't miss anything. These are the only things that are left over. So when we multiply everything across, we get negative 1 times 5 times 7, which is negative 35 over 1 times, remember there would be a 1 left down here. Negative 35 over 1 is equal to negative 35. So that's cool. We don't even have any variables left. And what that means is, for this problem, no matter what number you put in for x, you're always going to end up with negative 35 as your answer. The only exception for that would be 0, because you can't have 0 in a denominator. All right, let's look at one more. Very complex. Make sure you pause and try this one yourself. This might take a couple minutes. Negative 8x squared over 30xy divided by 24x over negative 25y squared. Right, pause. Try this yourself. I'm going to keep going. Again, I pause, I notice fractions, I notice negatives, variables, different variables, division. So one thing I know I can do is rewrite it as times the reciprocal of what came after the division sign. So I'm going to rewrite it as negative 8x squared over 30xy times, this is the one that we take the reciprocal of, so the negative 25y squared is coming up top. The 24x is going on the bottom. All right, so that's something I've done. I'm making some progress now. Now, man, doing the prime factorizations now is going to even be more important. So we have negative 8x squared. Negative 1, I'm just going to do the factor tree in my head. You might have to write these out. Negative 1 times 2 times 2 times 2 times x squared, remember, is x times x, over 30xy. 30 is 2 times 3 times 5, then times x times y. See how complex this is getting already? Times, now we do our next fraction, negative 25. There's that negative again. Take out a negative 1. 25 is 5 times 5. Y squared is y times y. Again, I pause, I make sure I look and make sure I got it all right. And then 24x on the bottom is 2 times 2 times 2 times 3 times x. If you didn't get those numbers, go back and make sure you did all your prime factorizations right, and that you only ended up with prime numbers on the bottoms of your branches. Okay, one of the biggest mistakes is not going all the way to prime numbers. Now we cancel. So, left to right across the top. Negative 1 can't cancel with anything on the bottom. I'll deal with it later. 2 cancels with 2. 2 cancels with 2. 2 cancels with 2. X cancels with x. Notice how I'm using a different color. You might find that useful, especially when you're trying to cancel an x. Don't write really tiny and cancel it with a pencil, and it just still looks like part of the x, right? Make it obvious. Keep going. X cancels with x. Negative 1's fine. 5 cancels with 5. And this 5 stays. Y cancels with y. Okay, so we're going to be really careful. There's a lot left over here. I want to make sure I get it all. We have negative 1, 5, and y. Those are the things left on top. 3, 2, and 3 on the bottom. So now we're going to multiply. And again, the benefit of doing the prime factorizations is that you don't have to reduce your answer. You don't have to simplify your fraction because you did it already. You don't have to work with these humongous numbers. You only have to work with the prime numbers. So what are we left with? Negative 1 times negative 1 is positive 1 times 5 times y is 5y over 3 times 2 times 3 is 18. There we go. Division with fractions with